Hey, my name is Laiba and welcome to Explore Technologies. I started internship at Cloud Native Islamabad. Moreover, I'm doing software engineering from Arid Agriculture University, Rawalpindi, Pakistan, and I have completed my 6 semesters. If you want to be notified whenever a new video comes out, then go and subscribe to my channel and don't forget to press bell icon. If you want to know what technology I'm currently working on, then go and check out my GitHub account. Wants to know more about Docker? Then go to my dev account and check out my latest article about Docker. You can also follow me on Facebook, LinkedIn, Twitter, where I share my everyday knowledge about technologies. So this is all on me. Now let's move to our video. I started my new journey, a Docker journey. So I decided to share my knowledge about Docker, whatever I have learned so far. So in this video, I will explain what is Docker, different components of Docker, VM versus container, and after installation of Docker, we will run some basic commands. We will discuss about what is Docker. So Docker is one of the most popular container implementation where we deliver software in containers, which simplifies the process of packaging everything it takes to run an application. From dev to testing to production, no conflict will arise because everything my app needs will be in a single Docker file, which we will explore later on. And that file can be version control, shared between different teams and move around between different environments. So it works exactly as expected. And moreover, there are numerous advantages of using a container to deploy an image. First of them is isolation. All the containers are completely isolated from each other, which means each application has its own libraries. No conflict will arise because the dependencies are in one place, and the dev and operation team are basically working on a same Docker file, which means reducing the risk of broken server and broken apps. And number two is limits on CPU and memory. Application may not hold resources from other application, which means we will set the codes within the Docker file that this container consumes this percent of RAM and that percent of CPU. And that container cannot go beyond what already provided in a Docker file. And a third one is portability. The container contains everything it needs and is not tied to an OS or cloud provider, which means whatever necessary for my application is self-contained in a single Docker file that can be moved around in different environments and can be shared between different teams and server and has no hard dependencies in OS and environment where it has to run. Ultimately, we are reducing the risk of broken server and broken apps. The last one is lightweight. The kernel is shared, making it much smaller and faster than a full OS image. Whatever I have shown you in this diagram, container doesn't need an extra OS to help me build and run my different applications. All it does is use the same OS and share the same kernel, making it much smaller than a full-blown VM. It takes milliseconds to spin up and milliseconds to tear down, as compared to a VM use or take minutes to boot up. So these all are different advantages. Now move toward next. Now let's move towards different component of Docker. There are different components like Docker file, image, Docker container, Docker engine, Docker CLI. So let's start with a very basic Docker file. Docker file is nothing but a simple text document that contains all the necessary commands which on execution help assemble a Docker image. We will dive into it in my future video. But actually, you list down the steps your app needed. Let's say first you clone the GitHub repo, pull down the required images from Docker Hub, and make sure to publish ports, set up some networking, some data your application needed, some secret your application needed. All these steps will be listed in a Docker file. All the steps you want your application to sequentially perform are listed in Docker file, which means some Docker files shared between different environment, different team, and which reduce the risk of broken server and broken images. And moreover, Docker image is basically a set of instruction which is used to build a container. It basically consists of application code with all its dependencies, libraries. It is a portable, so it can easily share between development team and operation teams. So the most important component of Docker is Docker container. Docker container is basically a way of packaging an application with all its dependencies and configuration files. A container is basically a running instance of a Docker image. Next component of Docker is Docker engine. It supports the tasks and workflows involved to build, ship, and run container-based application. The engine creates a server-side daemon process that hosts images, containers, networks, and storage volume. And the last but not least component of Docker is Docker CLI. Docker CLI is a command line tool that lets you talk to the Docker daemon in order to run the container-based application. That's all for Docker component. Now we will explain difference between a container and virtual machines. Most of the people are still confused about difference between VM and container. So let's overcome this confusion by understanding their corresponding architecture. Let's start with a VM. Here, the bird eye view of VM. We have our infrastructure in place: CPU, RAM, storage capacity, and network devices. On top of that, we need to have a technology which virtualizes our hardware, and that technology we now known as hypervisor. And now we need a way to provide a partition to our virtual hardware resources. And now we have 3 virtual machines in our stack, which means whatever hardware resources I originally have, I divide it up to 3 and make out 3 chunks now. Now I can install whatever OS, which will provide us a way to run more than one application in a single infrastructure or hardware. So now I'm using my hardware resources as efficiently as possible. But that comes up with severe headache of managing, configuring, upgrading, backup, and restoring of the VM and OS we have installed on top of it. We needed a full dedicated team and a support contract of 24/7, managing and configuring VM. If everything goes down in production, I will have to roll up my sleeves until the problem is fixed. That's great. That's literally great for larger teams and larger enterprises. But for small team, it's never going to be even possible. VM provided us a way to manage more than one application on a single infrastructure, but it comes up with a huge maintenance cost, a bigger headache. A bigger headache is that we can use our hardware resources as efficiently as possible. But do we, because I have no control, literally no control over VM. Let's say the app one running on VM1 uses 90% of CPU and 90% of RAM. But app 2 running on VM2 just uses 20% of CPU and 10% of RAM. And same like with VM3. There is a lot of unpack here in this small video. But all I want to take home from this video is first, VM solve the major problem, give us the flexibility to run many apps in single infrastructure. But the cost of managing, configuring, patching backups, and restoring the VM, plus we don't have our control on VM to make use of hardware as efficiently as possible. Also, VM images are huge GB in size and take hours to spin up and take minutes to tear down. We say VM great help us run more apps in a single hardware, but come up with maintenance cost plus app running on VM are not using efficient hardware resources. Let's now understand how containers solve these problems. First, we see in diagram in my right, we have our infrastructure that mandatory on top of it, we have installed OS, whatever you like. And new thing which you didn't see in VM architecture, that is container engine. As with hypervisor has this role to virtualize the hardware resources in a container world, container engine is responsible for virtualizing the OS, which means a lot, and that's huge. If you have come from VM background without installing the other OS, just sharing the same kernel with container engine, you can run as many apps as you can OS. Plus, you can provide limits to these container, that this container can consume that much part of CPU and that part of memory, and restrict containers to not go beyond the limits. Now, with containers, we have overcome both problems, making us of efficient hardware resources, plus removing the maintenance cost of managing, patching, configuring, and upgrading backups and restoring the OS and running of these virtual machines. So that's a huge benefits compared to VM. So, but now let's wrap up the container versus VM story by using, so all containers share the same kernel of the host OS, whereas in VM, each run in its own OS. Whereas, okay, in containers, startup time is in milliseconds, where VM startup time is in minutes. And in containers, containers are less secure, means provide process level isolation only. Whereas in VMs are more secure. Why? Because they are fully isolated from each other and the kernel is also separate. So, which is a good thing about VM. And in containers are lightweighted, means provide OS level virtualization. Whereas VM are not as much as like lightweighted. These are heavyweighted and provide a hardware level virtualization. So this is all about container versus VM story. So at the end of the video, we will discuss some basic commands used in Docker. But firstly, to install Docker, go to your browser and search Docker over here. Just click first link and click on products, then Docker desktop, and download it for Windows. And after downloading, just install it. I'm skipping all these steps because it's a simple next wizard on Windows. But if you find any difficulties while installing Docker on your Linux or Mac, Just go to Dosk, link is given below in description. Firstly, we will check what version of the Docker installed on my system. So for this, I use Docker variant command to view all the information related to Docker. Below in output, you see a client which we interact with it, and a server which will do the heavy lifting of running, stopping, starting the container. So this means we successfully installed Docker, and let's go ahead and explore some more commands. When I run Docker run Redis, it will do two things. First, it pulls the image from Docker Hub. But what Docker Hub is, we will dive into it in my future videos. But for this video, you just need to know it's a place where we store our images. But where did I provide information about Docker Hub in my command line? I didn't see that. Do you? So Docker is very opinionated about the registry. If you haven't specified where to get images from, it happen to be Docker Hub. Docker ps command is basically used to view all the containers present on your laptop. So here is my Redis container. If you want to remove a container, then firstly you should stop that container by using Docker stop and container ID. You don't need to write complete ID, but just a few characters from container ID. So here, my container stop. To view all the containers, either stopped, running, exited. So we use Docker ps and -a command. So here we can see that my container is successfully stopped. But let us say you are developing a demo app and test it out in a container. Works fine, great day, great feelings. And you don't want that container to hang on and consume your memory, CPU, and storage. You configure with it as we do it in Ages with VM. Just type a command docker rm and container ID. You can write few parts of container ID to remove a container. So our container will gonna remove. So let us check by our container successfully removed. So you are good to go, but you don't. One last command before I let you go. We saw how to pull and run images, but let's say for the next day you don't want to work with that image. So what will you do with that image? Either it will stay in your laptop for ages. No, I don't want it, and no, you also don't want it. For this, we should use Docker RMI and then image name to remove image from our system. So let us clarify about this Docker images, and now no traces left. Let me say again, no traces left, as it was never downloaded. Life is sweet, life is wonderful. Docker, you are great. I'm so lucky into this world where containers are in my machines. That's all about for today's video. In next video, we will explore how to containerize existing image. If you want to notified whenever a new video comes out, then subscribe to my YouTube channel. To know what technology I'm currently working on, check out my GitHub account. Want to know more about Docker? Then go to my dev account and check out my latest article about Docker. You can also join me on my Facebook, LinkedIn, and Twitter account where I share my everyday knowledge about technologies. So take care. Bye-bye.